A router, switch, hub, and access point can all connect devices, right? But they're absolutely not the same thing. In fact, if you put the wrong device in the wrong place, your network is just not going to work the way you expect. Welcome to the Explainer. Today, we're breaking down the absolute core of networking hardware so you know exactly what goes where.
Let's dive right into this. We've got 4 distinct pieces of hardware. So which one connects computers, which one connects whole networks together, which one actually gives you Wi-Fi, and why on earth do network pros say we should barely use hubs anymore? Well, we are going to solve that entire puzzle today.
All right, so here are the raw ingredients of a basic, everyday office network. We've got a desktop PC, a laptop, a printer, an IP phone, a smartphone, a server, and of course, our connection to the internet. Now, to really grasp what our 4 networking devices actually do, we're going to build this network from the ground up, piece by piece, just to see exactly how each device fits into the big picture.
Let's start with the oldest piece of the puzzle, the hub, or as I like to call it, shouting to everyone.
So, what exactly is a hub? Fundamentally, it's a Layer 1 device. It essentially acts as a basic multi-port repeater. And honestly, it has absolutely zero intelligence. It doesn't understand MAC addresses, it doesn't read IP addresses, and it definitely does not intelligently decide where your traffic should go. If computer A sends a signal intended for computer B, the hub just blindly regenerates that incoming electrical signal out to every single other port.
And this brings us to the core concept here. Hub equals repeat. Imagine standing in a really crowded room and shouting a message intended for just one specific person. Everyone in that room is going to hear it, whether they want to or not. That is exactly what a hub does with your network traffic.
Now, because a hub forces everyone to hear everything, we run into some severe disadvantages. The bandwidth, it's shared. You're stuck in what's called half-duplex operation, which just means only one device can send data at a time. If 2 devices try to talk at the exact same millisecond, boom, their electrical signals literally crash into each other. This causes collisions and creates a massive amount of unnecessary network traffic. Devices actually have to take turns using strict rules just to communicate. Because of these massive flaws, hubs are basically obsolete today.
So let's upgrade. Enter the switch, bringing us smart local delivery.
We are going to dramatically replace that old hub in our network with a modern Ethernet switch and instantly fix those collision problems. You see, a switch is fundamentally different from a hub. It operates primarily at layer 2 of the OSI networking model. Instead of just blindly repeating electricity, a switch holds Ethernet frames in its memory and forwards them intelligently using destination MAC addresses. This completely unlocks full duplex logic. That means devices can now send and receive data at the exact same time without their signals ever colliding. It's a total game changer.
Now, what's really interesting about this is how the switch dynamically builds a MAC address table. Think of it like a neighborhood directory. When a frame enters the switch, it looks at the source MAC address and logs it. It literally learns. It says PCA lives on port 1, PCB is on port 2, and the printer, that's on port 3. It continuously maps out the exact location of every connected device.
Here are the fast-paced microsteps happening inside a switch millions of times per second. Step 1. It examines the source MAC address of an incoming frame to learn where a device lives. Step 2. It looks at the destination MAC address and matches it to its internal table. And Step 3. It forwards the frame out only to the correct destination port. It completely leaves the rest of the network alone.
So if you remember one single takeaway about switches today, it should be this: switch equals MAC addresses. Switches are the ultimate high-speed controllers for connecting devices, like our PCs, printers, and IP phones, all inside a local area network, or LAN.
Now, actually, we do need a quick accuracy note here. What happens if a switch doesn't know where a MAC address is yet? If there's no matching entry in its table, well, it floods that unknown frame out to all ports just to make absolutely sure it gets delivered. It also does this for broadcast messages meant for everyone. But unlike a hub, once the switch gets a reply and learns the address, it goes straight back to targeted intelligent forwarding. To quickly summarize this evolution, let's compare the two. With a hub, one transmission goes to everyone. With a switch, it learns MACs and forwards intelligently. Put simply, a hub shouts, a switch delivers.
Moving right along to the router, also known as the Internet Gateway.
It's time to zoom out from our local LAN and introduce the device that allows our network to talk to the rest of the world.
A router is a layer 3 device. Its primary job is to connect entirely different IP networks together. And importantly, it makes its forwarding decisions using IP addresses, not MAC addresses. Think of routers kind of like the Postal Service. The switch handles moving traffic around inside your local neighborhood, but the router, it tells that traffic how to leave your neighborhood and travel across the highways to reach a completely different city.
Let's narrate the actual journey of a packet here. Step 1. Your PC asks, is this destination server on my local network? Step 2. When the answer is no, your PC encapsulates the packet and sends it straight to its default gateway, which is the router. Step 3. The router receives the packet, examines the destination IP address against its incredibly complex routing table, and sends the packet out on the absolute best path toward the internet.
So, the crucial point is this. Switches use MAC addresses. Routers use IP addresses. You absolutely need both. The switch gives you the high-speed local connectivity, and the router gives you the map to the outside world.
Beyond just basic routing, routers do a tremendous amount of heavy lifting for your network. They connect your local LAN subnets, say a 192.168 network, right to the internet. They serve as that essential default gateway we just talked about. They also perform network address translation, or NAT. They provide DHCP to dynamically assign IP addresses to your computers, and they often act as a basic security firewall, keeping all that bad traffic out.
And finally, the access point. Let's talk about going wireless.
So we've got our wired devices connected and talking to the internet, but we need to transition to the final device necessary for modern connectivity. A wireless access point, or AP, is essentially a bridge. It communicates with your wireless devices using radio frequencies and forwards their frames back and forth to the wired network. It's basically the invisible cable that allows your smartphone and laptop to access the wired switch and ultimately the router without ever needing to be physically plugged into the wall.
Bringing it all home with the complete office network. Putting it all together.
Let's see how this builds our final complete architecture. Here is our beautifully completed setup, with all the pieces perfectly complementing each other to make the network function. The access point connects the smartphone and laptop over Wi-Fi. It passes that traffic directly to the switch. The switch connects the PC, printer, IP phone, and that access point together locally, using MAC addresses for lightning-fast delivery. And finally, the router connects that entire local switch LAN straight to the internet using IP addresses. The whole shebang working in harmony.
It all comes right back to our first rule. Put the wrong device in the wrong place, and your network might just grind to a halt. If you try to use a switch to connect to the internet, you simply won't get there. If you use a legacy hub instead of a switch, your network will drown in collisions. So, take a look at your own setup right now, at home or at the office. Which of these devices is the biggest bottleneck in your current network? Really think about it. Thanks for joining me on this explainer. I hope it cleared things up, and I'll catch you next time.